Okay, so we are going to start looking today at some transformations of our quadratic functions. And so you have the function f of x is x squared, and that's going to be the quadratic parent function which is really the most basic function in the quadratic function. So where the only thing you have is the x squared. So to fill in this table, we're just going to square everything. So negative 3 squared would be a positive 9. Negative 2 squared is 4. 1 is 1. 0, 0. And then we go back up 1, 4, 9. And so as I graph that, I end up going in that parabolic shape. All the way up there, and I skipped an extra one there on accident. There we go. So that is our basic shape. It's not perfect, but it is still good. So every parabola that we have is a transformation of this. So when we look at any quadratic that we have, it's either just this moved up, down, left, right, stretched out, or flattened out, made wider, or flipped over. So looking at the key features of this, the vertex for this would be at 0, 0. Axis of symmetry, x equals 0. Domain is always all real numbers when we have just the regular formula. And all my y values are greater than or equal to 0. So in transformations, if I change the x value, causes a horizontal change, so move left and right. And then if I change the f of x or the y value, however you want to think about it, that causes a vertical change. And then those would both be called translations because it's the same thing, just moved up or down, left or right. So it's going to slide it horizontally or vertically, or just shift it. That's how we'll talk about it. So looking first at a vertical shift down here. If I do +4, so that takes the k value from 0 to +4, and move up here. And so a vertex is now 0, 4, and that goes up, shift up 4. That would also change my range to be y is greater than 4. -5, that would move it down 5. And so shift down 5. So the vertex is now 0, -5. And that would change my range as well for it to y is greater than or equal to -5. So the notation down here is what's going to be really helpful to you. So if it's the whole function plus a value there, which is really adding the k value, or f of x minus d. Plus is going to move it up. Minus is going to move it down. So they have it labeled as d there. You can think of it as the k value. Then the notation here, if I have, and I don't know why they have the different letters for it. Looking at these, if I do x minus 3, that's going to move it to the right. And so the shift right 3. Vertex is going to be 3, 0. And my axis of symmetry is also going to move with that. If it's plus 6, it's going to shift left 6. And vertex is going to move to negative 6, 0. And the axis of symmetry would change. So think of it as f of x minus c, where the c value is really just that h. Okay, and so if I do minus c, it's going to move it to the right. Plus c is going to move it to the left. And so when it says down here for each transformation, determine if the input or output is being changed and describe the effect. So basically, if it's outside the parentheses, that's going to be output. Inside the parentheses will be the input. So this is changing the y value. That's changing the x value. And we'd say it's shifted for this one down 17. Vertex would then be negative 0, negative 17. For this one, negative c would shift it right 1.7. So vertex would be 1.70. Okay, same for these. This would shift it left 3. That would shift it up 8. And they would change in a similar way. And finally, down here on the bottom where it says the linear parent function is translated 14 units to the left. So to the left means I add it to c. So t of x is going to equal f of x plus 14. And 6.8 units down here would just be f of x minus 6.8. So the notation here looks a little bit weird, but if you just think y equals x plus 14, then, and that would be squared, wouldn't it? So squared there, then you're good to go. So that is looking at translations and working through it like that.